Okay, ready Ready? Ready. Okay. So this is indeterminate structure course. Under this course, you have three topics. You have three topics. Topic for this course based on method. Okay, topic for this course based on method. If previously you have beam topic under solid mechanic, okay, you have truss topic, frame topic, arch cable under determinate structure, right? And you have topic name deflection, remember? Okay, where you use unit load method to analyze deflection or displacement in structure. Okay, so all this we will apply back into this course. Okay, so there are three topics as I already explained in Teams channel. Okay, so this semester I will not give lah. We will have module based on topic. So module 1 based on topic number 1, flexibility method. So why I put flexibility method as topic number 1? Because you will use this knowledge in lab. Okay, you are taking lab course, right? Okay, so some of the experiment that you will run in lab. So the theory that you need to calculate to verify the result that you get, okay, is actually come from this topic, flexibility method. Flexibility method. That is why I put this as first topic. Okay, and basically, if this is the first topic, end of semester, ramai yang already forget about what is flexibility method. Okay, so that is why I hope from the module you can use it to score lah. Okay, I hope you score. Okay, every semester I always said to students, this course is not tough. If you have strong basic in calculating reaction, in beams, in truss, in frame, you have learned about all this, right? Okay, calculate reaction, applying equilibrium equation, right? Applying equilibrium equation. So under this topic, flexibility method, you have to use that knowledge. We will calculate reaction in determinate beam, in determinate frame, in determinate truss. Okay? Okay, second topic is stiffness method. Second topic is stiffness method, and the last topic is moment distribution method. Okay, I believe if you are coming from diploma, okay, you have learned moment distribution method, right? So you need to refresh again lah. And of course, our focus is on the frame analysis, side sway frame analysis for moment distribution method. Okay. Second topic just now, stiffness method, basically matrix, based on matrix. So solution for stiffness matrix all based on mathematics. Okay, based on mathematics. Okay, so flexibility method ni, under this flexibility method, we will use all knowledge that you have learned previously, okay, including reaction in determinate structures. Okay, writing moment equation means internal forces in beam, internal forces in frame, internal forces in truss. Okay, you have to know how to write moment equation in beam and frame, and you have to know how to determine axial forces in truss, determinate truss. Axial forces using method of joint, not method of section. We use method of joint. Okay, we use method of joint to solve for problem in flexibility method. Okay, apa lagi? Deflection. So deflection, we will apply what you have learned previously under unit load method to calculate rotation, to calculate horizontal displacement, to calculate deflection, right? Okay, so we will adopt okay, that principle of virtual work, and we adapt into flexibility method. Okay, so inshallah the first module I will send to to print this by this week. So by next week, insyaAllah, we're ready. So dia book, not binding rim, yeah. It is a book. Okay. So that is the price also I have put in the Teams. So please check, yeah. So by next week lah, by next week. So by this week kita tengok introduction first, because in flexibility method, the understanding about what is flexibility method is very important. Even though we have 4 type of structure that we need to analyze. Start with beam, and then frame, and then truss, and then we will touch a little bit about composite structure, which is combination of element in truss plus frame, element in truss plus beam, yang tu composite structure. Okay, but what most important is the concept. What is actually flexibility method? Okay. Any question? Do you have any question? Okay, let's look at the learning outcome first. Learning outcome. So learning outcome is very important. So means that at the end of the topic, you must know what you have learned. Okay, tak boleh end of topic you do not know. Tak tahu 5 minggu ni belajar apa. This is for 5 weeks, yeah. This is for 5 weeks. Okay, so number one. Okay, number one. Degree of indeterminacy. Calculate degree of indeterminacy. Degree of indeterminacy. Have you learned about degree of indeterminacy previously? What is it for? What is it for? To? Yeah? Okay. To determine determinacy of the structure. We want to know whether the structure is unstable, determinate, or indeterminate. Okay? We calculate degree of indeterminacy. Okay? So degree of indeterminacy ni is very very important, because from number of degree of indeterminacy, we will identify redundant. Okay, redundant. What is redundant? Redundant is very very important. The key word in flexibility method is redundant. The key word means that everyone must understand what is redundant. Okay, and number of redundant in the structure depending of number of degree of indeterminacy. Okay, so we focus on indeterminate structure, means when DOI is equal to 0, we get determinate structure, right? DOI equivalent to 0, determinate structure, right? DOI equivalent to 1, indeterminate structure. DOI is equivalent to 2, indeterminate structure. Okay? Okay. So DOI equivalent to 1 means there is 1 redundant. DOI equivalent to 2 means there are 2 redundant. Okay? 2 redundant. Okay. Okay, that is the first keyword. Redundant. Okay? Redundant. Okay. Okay? Okay, number 2, number 2. Learning outcome number 2. Okay, you have to understand the keyword number 2 under flexibility method. It is primary structure. Primary structure. Primary structure. This is keyword number 2. Primary structure and redundant structure. Okay, so when we analyze beam, it is primary beam, redundant beam. When we analyze frame, we have primary frame, redundant frame. When we analyze trust, we have primary trust, redundant trust. All are structure, right? Okay. So this is keyword number 2. Number 2. Group lah, primary structure and redundant structure. And primary structure and redundant structure, okay, both are determinate structure. Ini determinate structure. Dua-dua ni determinate structure. Both are determinate structure. Primary structure and redundant structure, both are determinate structure. Okay, determinate structure. Okay. Okay. Okay, keyword number 3. Keyword number 3. Keyword number 3, compatibility equation. Compatibility equation. This is keyword number 3, compatibility equation. Okay. So you must remember all these keywords. Number 1 is redundant. Number 2 is primary and redundant structure. Number 3 is compatibility equation. Okay. Compatibility equation, sometimes it is also called as flexibility equation. Compatibility equation is also called as flexibility equation. Okay. And we will derive this equation. We will derive this equation from principle of superposition. Okay. From principle of superposition. Okay. Nanti modul nanti please read. Okay. Saya buat 5 topics for flexibility method because we have beam, frame, truss, composite structure. Plus topic number 1 is introduction. Okay, introduction tu ada explain all about this, what is redundant, what is primary structure, redundant structure, compatibility equation, how we derive the compatibility equation. So all I have explained under topic number 1. Okay, so topic number 1 tu saya explain by taking beam as example. Okay, and actually the derivation of the compatibility equation tu I will only derive from beam. And after once you understand how we derive that, okay, we will apply to all type of structure. Okay, compatibility equation ni kita derive. Saya nak tunjuk macam mana kita derive. Tapi untuk jawab soalan you tak perlu derive pun. Okay? Because every question have unique every problem, every structure have unique compatibility equation. Okay, so that is why saya akan tunjuk from derivation. Okay, so number 4, keyword number tadi berapa dah? Redundant, primary and redundant structure, compatibility equation, right? Okay, 4. Okay, keyword number 4. Keyword number 4, displacement. Keyword number 4 is displacement. Okay, keyword number 4 is displacement. Displacement in primary structure and redundant structure. Okay, redundant structure. Redundant can be 1, can be 2. Can be 1 redundant, can be 2 redundant. Okay, depend on DOI tadi. Okay. 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 After that, this displacement ni kita akan calculate guna unit load method tadi ya. Okay, unit load method. We do not call it as unit load method because we adopt and adapt into this topic. But basically, the formula will be the same. Just notation that we use for the M and N will be different. Okay, so displacement. So this displacement, basically, compatibility equation is based on displacement at redundant position. Displacement is not one. Displacement depending on how many determinate structure that we analyze. Displacement. Okay, kalau ada primary structure, redundant structure, two system. Means there are two displacement. displacement. Okay, if we have 2 DOI, we have 6 displacement. If we have 2 DOI, we have 6 displacement. So this displacement, we substitute into compatibility equation. We substitute into compatibility equation. Okay? Compatibility equation. And by solving compatibility equation, we get the redundant. So determine redundant ni, yang ni, determine redundant, number 5. Determine redundant, number 5. Okay. So we determine redundant by solving compatibility equation. Okay. If one redundant, one equation. If two redundant, two equation. Two simultaneous equation. Two simultaneous equation. Okay. So once we get redundant, we will continue to calculate remaining reaction. Okay. We must remember that when we analyze indeterminate structure, nak tulis tak sedap ni, berdiri bongkok-bongkok ni. Okay. Macam ni kan, cantilever beam. Cantilever beam. For example like this. Cantilever beam. How many unknown reaction for this? 3. At fixed support. Right. At fixed support, right? 1, 2, 3. 3. Okay, this one, the DOI is equivalent to 0, right? 0. 0. Okay, so these 3 unknown reaction can be solved using 3 equilibrium equation. Jangan kata tak ingat kira reaction ya. You must know how to calculate the right reaction. Okay, jangan exam tiba-tiba exam reaction pun tak boleh kira. Okay, so we calculate these 3 unknown reaction using 3 equilibrium equation. Right. So what are the 3 equilibrium equation? Moment 0 lagi. Fy 0 lagi. Fx 0. Okay. Okay. Now, I want to put one roller. Okay. Now, I want to put one roller kat sini. So, what happened now to the beam? What happened now to the beam? Equivalent to 1. Equivalent to 1. 1. 1. Okay. So, yang extra tu is redundant. Without the redundant, can we analyze the 3 remaining reaction, the 3 unknown reaction at A? Without this roller, can we calculate AY, AX, MA? Ini AY, ini MA, ini AX. Without roller, can we analyze? Without roller, without. Roller tak ada macam ni. Original. Macam ni tadi. Without roller. Yang ni, yang bawah ni. Boleh calculate tak unknown reaction? Boleh calculate kan? Boleh calculate kan? Okay. When I put roller at B. So sini B Sini B. Sini A. When I put roller at B, can we analyze 4 unknown reaction? Can we analyze 4 unknown reaction? No, cannot. Because of the redundant. Okay? Because of the redundant. Without redundant, can we analyze? Without redundant. Kalau roller tu saya remove, boleh calculate tak lagi 3 tu? Boleh calculate kan? Boleh calculate. Saya nak remove BY. Remove BY boleh calculate Boleh calculate. Okay. So in this case, BY, in this case, redundant is the problem. Redundant is the problem. So when redundant is the problem, we need to solve the redundant. Okay? We need to solve the redundant. Okay, dia punya idea macam ni. Okay, bila kita ada determinate structure, determinate beam macam ni, cantilever beam, right? We have 3 unknown reaction. And these 3 unknown reaction can be determined using 3 equilibrium equation. Now, we have 4 unknown reaction. We have 4 unknown reaction. Can we calculate these 4 using 3 equilibrium equation? No. We cannot calculate 4. We cannot calculate 4. So, minus 3 that can be solved using 3 equilibrium equation. So, remain, yang ni redundant. Yang ni redundant. Itu dia punya idea, flexibility method. Okay. 4 cannot be determined. So, 1, this redundant is the problem. Solve this redundant. Okay. After solving this, then only you can solve the 3 remaining reaction. That is the idea. So, if you want to answer what is flexibility method, it is simple. It is actually, we cannot determine 4 unknown reaction using 3 equilibrium equation. And that is why flexibility method take place. Semua tu saya tulis dalam nota. Nota ni you boleh access from your devices. Saya dah upload semalam dekat sini . This is OneNote. So you boleh install OneNote in your device. OneNote, and nanti you pergi cari nama team channel kita tu 20232 indeterminate structure, nampak kat atas tu kan. Okay, so you tengok pada content library. So ada flexibility method. So saya dah letak textbook kat sini, textbook chapter number 10. Okay, chapter number 10 ni flexibility method . Chapter number 10 is flexibility method, and introduction yang sekarang kita discuss, saya dah letak kat situ. Okay, last semester juga saya buat macam ni, tapi ramai yang maybe tak tengok pun. Dan bila exam macam tak pernah tengok langsung. Okay, that is why this semester saya wajibkan semua guna modul tu. So lepas dah ada modul, so semua example, semua discussion kita will be based on modul tu. Okay, of course we do not have time to discuss semua example yang saya bagi. At least you boleh tengok for your guidance lah. And saya juga sediakan sekali dengan calculation sheet, soalan dan juga calculation sheet yang ada dia punya step. You just follow the step. Okay, hopefully it will help you lah. Okay. So before next week tu, tengok kat sini lah. Okay. And actually under this is all your folder. Kalau you ada buat extra exercise ke apa, you boleh letak dalam ni lah. Okay, anyway, bila ada modul tu, I believe kalau you betul-betul guna modul tu dengan baik, insyaAllah you boleh sukses lah. Okay. So semua explanation dia ada kat bawah ni. Tapi kena baca lah. Okay. And saya prepare this notes, bukan saya rujuk buku dan salin balik, no. Saya tulis balik based on my understanding. So saya dah ringkaskan, dah mudahkan. So I believe kalau you betul-betul read this note, you boleh understand apa yang saya cakap ni sama macam apa yang ada kat dalam ni. Okay. Okay, malam ni, so normally apa yang kita belajar pagi ni, so malam ni kita ada aktiviti, so saya akan tanya balik lah dalam bentuk quiz guna class point. So you kena jawab lah within the time given, mungkin 1-2 minit depend on question. Okay, so nanti kita akan buat aktiviti tu. Saya set kelas malam tu sekali jalan 8.10. 8.10 dua-dua kelas. Tengoklah malam ni kalau tak sempat ngam-ngam 8, kita mungkin start lewat sikit kan. Okay, kita akan combine 2 classes lah. So maybe 1 hour for activity. Kalau ada keperluan untuk kita tengok example, kita akan buat another 1 hour lah. Kalau tak, satu jam je lah. And for night classes tu, please tick your future tu ikut your timetable. So kalau your time is 8 to 9, masa tu you tick your future. Okay, kalau yang kelas dia 9-10 lah. Okay, so yang ni jangan lupa tick. Okay, so kita tengok sepintas lalu yang ni nanti, so that bila you dapat nota tu, you baca, you akan boleh refresh balik lah. Okay, so flexibility method, this is the classical consistent deformation method for computing reaction and internal forces. So flexibility method, even though dalam step-step tu ada displacement, tapi bukan itu dia punya objektif. Because objektif kita nak calculate redundant, and redundant is forces. Extra reaction dalam structure tu, redundant. Kalau kita ada tadi beam kan, beam yang ada fix dengan roller, so ada 4 kan. So kita nak kira reaction yang keempat ni. Itu flexibility method. Okay, even though ada step displacement dalam flexibility method, bukan itu final objective. Itu part of step. Tapi objektif dia, kita akan gunakan flexibility method untuk calculate reaction as well as internal forces. Internal forces ni kita fokus pada thrust, because axial forces in thrust can be the redundant as well. Okay. So yang nombor 2 tu, a structure of any type is classified as statically indeterminate when the number of unknown reaction or internal forces. Kalau kita analyse beam and frame, kita fokus only for the reaction. Okay, internal forces yang kat sini mention, this is introduction, apply to all. So internal forces ni for thrust. Okay, for thrust. Because thrust, redundant dia tu can be internal forces, can be reaction. Okay, exit equilibrium equation. Tadi dah explain. Exit equilibrium equation. Equilibrium equation, we only have 3 and we have 4. 4 we cannot calculate using 3. That is the idea. Okay, flexibility method is one of the several techniques available to analyze indeterminate structure. The following is the procedure that describe the concept of this method for analyzing. Okay, kalau for beam, it is externally indeterminate. Beam frame externally indeterminate. Apa maksud externally indeterminate? Ini maksud dia redundant to reaction. Because reaction is come from external force. For example, kalau you ada cantilever beam yang tak ada loading, ada tak reaction? Ada tak reaction? You ada cantilever beam macam ni, tapi tak ada loading, ada tak reaction? Zero kan? Zero. So bila ada loading, for example ada loading ni we call it as external force, right? External load. So when this beam has is subjected to external load, that is why we get reaction value. Ada moment semua ni kan? Ada moment. So in this case, this is externally indeterminate. So bila ada roller pula kat sini, so dia akan jadi externally indeterminate. Okay, so we have another one called internally indeterminate, yang tu untuk thrust. Okay, this flexibility method is sometimes called as force method. Force method is another name of flexibility method. Force method is another name of flexibility method. That is why if you refer to the chapter in the textbook under chapter number 10, okay, it is called as force method. Okay, external force. We calculate reaction from external force. It is force. Redundant is force. Reaction to force kan? Forces, right? Okay, that is why it is also called as force method. Okay. Okay, removing. Flexibility method involve removing enough restraint. Means that kalau dia 4, Berapa nak kena remove? 1. Okey? Kalau 5, berapa kena remove? 2. Remove bagi jadi determinate. Bila kita remove, structure tu berubah from indeterminate jadi determinate. Okay? So, after removing redundant, structure yang kita lepas kita buang redundant, dia jadi primary structure. Tadi keyword dia primary structure kan? Okay, ada 4 unknown reaction. Dia kata kat sini, removing enough restraint, buang 1. Okay? Removing enough restraint, buang 1 jadi 3, right? Okay, dia dah jadi determinate structure, right? So, this determinate structure is called as primary structure. Primary structure. Okay. And of course, it must be stable. It must be stable. Okay. So, I have explained this. Okay, using the previous example I given to you, right? Okay, this is cantilever beam where we have 3 unknown reaction at fixed at A. We have MA, we have AS, and we have AY. Okay, and this beam is subjected to point load at B, 10 kilonewton. So we can calculate this reaction. Okay. Now, consider beam in figure 1.2. Beam has extra support. Beam has extra support. Okay. Roller. Roller. So I put roller at B. I put roller at B. Okay. When there is a roller at B. So now when we calculate for DOI. When we calculate for DOI. It will be equal to 1. 1. Means that when we analyze beam and frame. Okay, you don't need to remember formula yang pening-pening, no need. So you just need to find the difference between total reaction in the system and minus by 3. Minus by 3. So it is R minus 3. 3 tu is 3 reaction that can be solved using 3 equilibrium equation. So in this case, it is 4 minus 3. It is equivalent to 1. Okay, this one is redundant. Means that we have to remove one reaction from this beam. Okay? Okay, nampak tak kat situ? Okay. Saya dah explain the 3 above mentioned in the formula shows that there are 3 unknown reaction. 3 unknown reaction that can be solved using 3 equilibrium equation. That is the definition of 3 in the formula. Okay. Okay, DOI equal 1 means there is one redundant. And this redundant will be determined by applying principle of superposition. Okay, remember we have to identify how many redundant in the system. Identify the redundant, remove the redundant, and then we will determine the redundant by applying principle of superposition. Okay, so when DOI is equal to 1, the beam in the figure is called as an indeterminate beam to the first degree of indeterminacy. To the first degree of indeterminacy. Kalau the 2 redundants, to second degree of indeterminacy. Normally, for flexibility method, we can limit up to 3. Because 3 can be solved using 3 simultaneous equation, right? 4 cannot, 5 cannot, right? So we limit the redundant up to 3. But normally, 2 and 3 have similar analysis. So we will do Most of the time we will do 2 redundant. Okay, 2 redundant. 1 and 2, focus on 1 and 2 redundant only. Okay, so now we move to what is actually principle of superposition. Pernah guna this principle previously? Pernah jumpa kat mana-mana? Pernah dengar sebelum ni? Pernah dengar sebelum ni? Okay, so kat sini saya ada bagi example. Okay, actually kalau you search for principle of superposition, you akan nampaklah the concept ni. Because principle of superposition ni, we apply not only for this topic. So this is one of the famous concept that we apply in structural engineering. Memang banyak apply this principle of superposition. Another topic that also apply this principle is moment distribution method. Okay, tapi cara apply tu berbeza lah, tapi masih lagi principle of superposition. Okay. Okay, remember we remove redundant because we want to solve for the redundant. Redundant will be determined first. Redundant will be determined first. We will determine redundant by solving compatibility equation, and compatibility equation is based on principle of superposition. So now kita nak masuk dekat derivation. So derivation ni is very important. The derivation. Okay, solution tak pakai derivation, tapi you must understand the derivation. Okay kot, cukup lagi kot. Lagi 1 jam. Okay. Okay, diagram ni is actually ada dalam textbook. Saya ada buat sikit modification to the symbol used. Okay, sini. Okay. So this is principle of superposition. Okay. So look at diagram A. Cuba tengok diagram A ni. Okay. Diagram A. Okay. An indeterminate beam we call as actual beam. Actual beam, soalan tu yang you dapat tu is actual beam lah. Indeterminate structure, indeterminate beam is actual beam. Okay. Tadi kita dah belajar that redundant need to remove. To be removed. Kan? Need to be removed. Okay. So bila kita remove, so we can actually remove either BY or MA. Sebab remember, beam ada 2 types of determinate structure, right? Beam ada simply supported beam, remember? Beam juga ada cantilever beam, right? Okay. So dua-dua ni boleh jadi primary structure. Primary structure can be simply supported beam. Primary structure can be cantilever beam. Dia kena stable lah. Bila buang satu, kan dia ada 4 kat sini. Dia ada MA, dia ada AY, AX, MA. BY, right? Ada 4, right? Okay, can we remove BY? Bolehlah remove BY because bila kita remove BY, dia jadi cantilever beam, right? Okay, can we remove MA? Bila kita remove MA, dia jadi simply supported beam. Okay? Can we remove AY? No. Dia jadi unstable. Kan? There is no support. Okay? For this, there is no support. Okay? So AY cannot be the redundant. Okay? Sama juga, boleh tak remove ni? Tak boleh. So moment dengan Y, moment dengan AY cannot. So kalau fix, we must remove moment. kalau yang kita nak buang tu is one reaction from fixed, kita kena remove moment. Okay? Moment. Remove moment jadi simply supported beam. Okay? Or kalau kita nak remove BY, dia jadi cantilever beam. Okay? For the derivation, I will choose cantilever beam as the primary beam. Okay, primary beam. Okay, yang ni primary beam. Kita dah remove BY. Okay, we have removed BY. Dia jadi cantilever beam. So, dia ada dua option kat atas ni kan. Nampak tak ada dua option tu? Kita ada option number 1, kita ada option number 2. Okay, ada dua option. Okay, so simply supported beam and cantilever beam, dua-dua tu primary beam. Okay, tapi for derivation saya choose number 2. Okay, kita fokus on cantilever beam. Okay, so primary beam diagram B. So because the roller has been removed, just remove BY. Bila kita remove BY, dia jadi cantilever. Bila dia jadi cantilever, bila ada P on top of the B, what happen? Ada deflection. Okay, redundant yang kita remove tu, position dia pada B. Redundant position. So kita kena tengok, kita kena mark, kita kena calculate displacement at B. Okay, so kita label as delta B naught. Okay, dia ni ada dua notation dalam ni. The notation is B, the second notation is not. B0 tu kan. We call it as delta B naught. There are two notation. Number 1 is B, number 2 is not. Okay? Okay, dua-dua notation ni ada definition. Okay. The first notation refers to position. Position dia di mana? Di B kan? Di B. Deflection tu dekat B. Sebab apa kita pilih B? Redundant dekat B tadi. Okay. Okay, second notation not. Okay, semua definition ni ada dalam nota ni. Saya dah tulis. Okay. Delta B not. Okay, station not. Station is for type of beam. So kalau simbol dia delta B not, automatically kita tahu yang position dia dekat B. Diagram tu is primary structure. Not ni is always symbol for primary structure. Not is primary structure. B not means position dekat B, primary structure. Delta B not. Okay? Okay, sekarang ni B ni sama ke dengan A? Sama tak dengan A? Tak sama kan? So tak sama. So yang kita namakan dia principle of superposition tu, kita kena tambah dua-dua dapat balik A. Okay? Okay, next is redundant beam. Okay. Pada redundant beam, okay, this redundant BY applied. Okay, kenapa jadi put roller, but we put as an applied force, applied load B. Kita tak kan ada BY kan? Roller ada BY kan? So kita jangan letak roller balik kat situ, no. Kita letak by. And by, we assume as applied by that is subjected in the cantilever beam. Okey, dua-dua diagram ni mesti sama-sama cantilever, sama-sama simply supported beam. Tak boleh lain-lain. Primary structure, redundant structure, dua-dua ni tambah dua-dua ni dapat actual beam. So dua-dua ni determinate structure, dua-dua ni cantilever beam, dua-dua ni simply supported beam. Okay, so kat mana beza? Beza pada loading. Okay, primary structure subjected to external loading, redundant structure subjected to by. So that bila kita tambah, okay, bila kita tambah, okay, tengok diagram ni ya. Bila kita tambah ni, P plus 0, we get back P in actual beam. Okay. Now 0, sini 0 kan? Sini 0. 0 plus by. Dapat balik sini by. So that is principle of superposition. Okay. So we must remember primary beam and redundant beam both are determinate beam. Same type of beam. Determinate beam. Stable. Okay. Different in loading. Primary structure, okay, is a determinate structure subjected to all external loading. Yang kita remove is only the roller, the redundant. Okay, redundant beam, we call it as redundant by applied. Okay, so that we know that the by that we put is an applied by, not roller. So we will calculate delta based on this by. So you jangan anggap ni roller, you anggap ni by. Bila ada by, ada force, contoh ada force 100 kat sini contoh kan. Ada tak displacement? Adalah kan? So dia akan deflect, so dia ada displacement. So this displacement is called as delta BB. Tadi B naught kan? Tadi sini B naught, right? Now delta BB. Kenapa BB? Okay, dua notation, remember? Two notation. First for the position, second for type of beam. So B yang nombor 2 tu, BY applied tu lah, kita ambil B tu. Okay? So that is principle of superposition. Nanti bila you buat example, you akan faham more about this. Okay, biasalah first time pening tu biasa. Tapi kalau sampai hujung sem pun masih pening tu luar biasa. Okay, kalau you rasa ada problem, still tak faham, okay, tengok video pun tak faham, ada more than 100 video dalam my YouTube channel tu. Saya start buat video since 2017. So you boleh tengok. Okay, saya mengajar Shah Alam last 2 semester juga. This course juga di Shah Alam. Tapi kod lain lah, kod lain. So ada video-video dalam tu you boleh tengok. Okay. Because every session normally saya akan use different problem. Okay, so boleh tengok lah. Okay. Nanti baca, saya tak baca dalam ni lah, nanti you baca balik. Okay, kita nak tengok derivation tu. Ni semua ada explanation apa dia remove, apa dia label-label, notation semua ada, saya dah tulis kat sini. Okay, so saya dah detailkan juga kat sini what is primary. So roller has been removed. Okay, external loading remain. So saya dah detailkan kat sini. Okay, sama juga redundant structure pun saya dah buat detail dekat sini. Okay, redundant structure. So by is applied, by. Okay, lepas tu the next keyword tadi kan displacement kan? Displacement. Okay, displacement at redundant position. Convert dulu delta BB menjadi FBB kali BY. Okey, dia macam ni kat sini Sini careful, bukan careful, yang sini okey, beri perhatian sikit kat sini. Okey, it is for redundant beam. It is for redundant beam. Sebab okey, kita ada dua determinate structure. Dua determinate beam, right? The first one is primary beam. The first one is primary beam. Primary beam ada external loading. Kan? So all external loading ni, can we calculate reaction? Can we calculate reaction? Okay, my question is, can we calculate reaction for primary beam? Yes, because external loading tu value given, right? Okay. For redundant beam, due to By is unknown, right? Can we calculate reaction based on By? No, cannot. Okay. So, what we need to do is we have to apply. Yang ni saya just inform you lah. So, bila solution terus ambil yang yang ada sempat. Okay. By times By. By. Sini By. Sini By. So, kita take up kita tahu, can we calculate reaction due to a unit value? Boleh lah kan? Sama macam virtual work method, remember? Virtual system kita calculate reaction. Kan? Virtual system kita calculate reaction due to a unit value, right? Okay, now kita akan, that is what saya kata, kita adopt and adapt. Kita tak pakai dia sebiji dalam ni, no. Okay, virtual work method is to calculate displacement, right? To calculate displacement, and we apply a unit force. Now, a unit force kat dalam ni is a unit value of By. So, yang ni of a unit value of By. So, kita akan analyze the second diagram. The second diagram, not the first diagram. So, we take out By. Kita tinggal satu je dalam tu. Just like virtual system. Tapi virtual system tak ada kali something-something dah kan? Yang ni kali redundant. Kali redundant. Okay. So tengok apa lagi perbezaan dua diagram ni. Kalau yang tadi By delta, when we change to 1 times By, 1 times By means a unit value of By. A unit value of By. Maksudnya kita take out By. Kali By. Hanya pada satu. Tapi for the whole. Okay, bila kita apply for the whole, kalau yang ni tadi, delta BB, due to a unit value, dia bukan lagi delta BB. Dia jadi FBB. Berubah simbol daripada delta kepada FBB due to a unit value. Nampak tak sini? Yang ni Yang ni. Okay, it is a unit value of By. So By tu apply to the whole, not only for a unit value. So means that deflection pun kena kali dengan By, baru dapat balik delta BB. Dia macam ni lah. 1 kali By sama dengan dia, kan? So kat sini delta BB. So sini BB. Sini ada apa? FBB. So, remain lah, yang ni remain. So yang berubah yang ke depan. Yang ke depan. Okay. In the analysis, we do. So F ni displacement. Sebab apa kita pakai F? F for flexibility. F for flexibility, it can be displacement, it can be rotation. Okay, dia displacement, sama formula. Okay, pakai simbol F not delta. Okay. So, detail dia ada kat sini. Atas displacement principle. Okay. Okay. Ini dulu dah sampai hari ni, untuk pagi ni, sampai sini dulu. Saya nak you betul-betul understand yang tadi tu yang kita bincang tadi. Saya tak nak move to the derivation. Saya rasa derivation tu akan ambil sikit masa. Di bawah ni, derivation akan ambil sikit masa. So kat sini saya dah explain in detail. Okay, okay, kita akan sambung this derivation not malam ni lah. Malam ni boleh you stay 2 jam tak? 1 jam for activity, 1 jam for derivation. 8.30 maybe sampai 10.30. Is it okay? Okay, so derivation kita buat online ya. Derivation online. So lepas tu kita terus buat example lah. Example. Okay. Actually today first day school, saya ada anak standard 1, darjah 1. Saya pun quite rush juga nak balik hantar dia pergi sekolah for first day lah, day 1 at school. Pukul 12.30 ni kan. Okay, so I hope you understand what we have discussed. Okay, for the 1 hour session ni. Okay. So semua yang kita discuss tadi saya nak tanya balik tau malam ni. Okay. Saya akan tanya balik soalan-soalan yang based on apa yang saya discuss pagi ni dengan you all. So please tengok balik video ke, tengok balik nota ni ke, bincang dengan kawan ke, it's up to you. Okay, kumpul bintang ya. So aktiviti kita malam ni saya akan pakai class point. You scan je nanti QR code saya bagi. So akan ada quiz yang akan appear dekat your phone. Nanti you jawablah soalan tu. So betul dapat bintang lah. Okay, semua compulsory. Make sure you score lah. You score. Saya nak tengok dulu performance macam mana. Kalau semua contribute, okay. Kalau ada yang tak nak contribute, saya akan count bintang tu for attendance. Tapi depending on you lah. Okay, I hope 100% contribution and hopefully 100% attendance also for the whole semester. Kalau ada emergency sangat-sangat, kena tunjuk surat lah. Okay. So this session you boleh tengok balik, ada dalam link yang saya dah bagi dalam group tu. You please join Telegram channel, yang mana dekat Telegram channel tu saya dah letak semua link video-video saya. Okay, you boleh tengok juga dekat YouTube. Tapi ada some video yang saya set unlisted, so kalau you search tak jumpa. That's why saya letak dalam Telegram channel. So dalam tu semua ada link-link dia. Okay, so if you have question, actually saya tak berapa, saya tak nak kalau boleh pakai WhatsApp group. Ada yang tanya kan? Saya nak fully utilize apa yang kita dapat, Microsoft 365. And dalam Teams tu ada macam-macam section, boleh buat kan macam-macam kan. So proper kat situ. So please you tengok kat situ lah ya. If you have any question, kalau you nak personal tanya soalan and you segan nak tanya dalam Teams channel tu, you boleh guna Teams chat. Tapi saya lagi suka if you tanya dalam Teams tu. So that yang lain-lain pun boleh baca kan. Komen dan boleh baca. Okay? Boleh ya? So any question before we end session? Any question before we end session? No question. Okay, so that's all for the first session. Inshallah we meet again tomorrow tonight, not tomorrow night. Tonight ya, tonight. Okay, inshallah. So thank you very much.